We're continuing our journey with trig equations, and we're looking at restricted domains now. So here's an equation to solve. Basically this video will be pretty much just solving. So 4 plus 4 sine theta equals 2 for a restricted domain between 0 and 2 pi. So we're going to be working in radians and we're solving for theta. So the first thing I want to do is rearrange and simplify a bit. So we've got 4 sine theta equals -2, subtracting 4 from both sides, and sine theta equals -2 on 4, or -1/2. Okay, and with our unit circle, we've got sine is negative in quadrants 3 and 4. So we're looking at acute angles there, and sine of pi on 6 in the first quadrant equals 1/2. So basically we've got pi on 6 as the acute angles there and there. So the first angle, theta is, pi plus pi on 6, which is 7 pi on 6, 6 pi on 6 plus 1 pi on 6. Theta also is 2 pi take pi on 6. You can see that angle there if we go clockwise, which is 12 take 1, which is 11 pi on 6. So the two solutions are 7 pi on 6 and 11 pi on 6. And let's just check if they're in the domain 0 to 2 pi. Yes, they are. They are also the only solutions in that domain. So if we look at coterminal points, they'd in either direction they'd go outside of 0 and 2 pi. Another example. So we've got degrees here. We're solving for x, and first thing we're going to do for √2 cos x equals 1, we're going to divide both sides by √2. So cos x is 1 divided by √2, or 1 over √2. So thinking about exact values and unit circles, we've got a couple of things of note there. We know that cos of 45 in the first quadrant is 1 over √2. We also know that we have a positive value there, so we're looking at quadrants 1 and quadrants 4 for cos. So due to some symmetry there, we've got 45 degrees there, and we've got an acute angle of 45 degrees there as well. So x equals 45 degrees. X also equals 360 take 45 degrees, which is 315 degrees. However, take note of the restricted domain. So does that mean we've only got one value that's valid? No, because we can also write this in terms of negative angles. So write it as -45 degrees, and then you satisfied the solution's domain. Next one, we've got 3 to go. We've got 3 sine x plus 1 equals 0, and we've got a restricted domain solving for x. So we have 3 sine x. We have to subtract the 1 first, and then divide by 3 both sides. So sine x equals -1/3. Now this is one of those ones, it does not correspond with the exact values. You will get these sometimes, so you are forced to resort to decimals. So make sure we're in radians mode, because you can see there There's a hint. And for the first quadrant, quote unquote, we're going to look at what happens if we find the inverse sine. So basically what we're going to do is find the inverse sine of negative 1/3 using our calculator. This will give us a value in the principal domain, as mentioned in the previous video. So see the beginning of the previous video. So that's the solution for the principal domain. It may not be the solution to this equation, but it gives us a point on which we can start. So inverse sine of, so go. Okay, and so we've got to take the inverse sine here. Okay, so I'm going to take that answer there. We've got, I'll go to 4 decimal places, 0.33, negative 0.3398. Now we need to work with that. That's in radians. So referring to our unit circle, we've got sine is negative. Sine is negative in quadrants 3 and 4. 3 and 4. I was right the first time. So let's look at how that comes out. So we get our calculator, work out the decimal approximation. So we got pi plus 0.3398. Get 1.0675. Sorry, that's clearly wrong. It's 3.481. 3.481 approximately equal to, and 2 pi take 0.3398. So 2 pi, sorry, I'm using not a very good calculator here. So 2 times pi take 0.3398, and we get 5.943. 5.943 approximately in rate. So again, if it wasn't clear before, we get the magnitude of this angle. It may or may not have a negative on the front, but we stick to what we know about the unit circle. These angles in this case must have been in quadrants 3 and 4. Okay, what about some action involving tan? So tan x equals root 3 between 0 and 2 pi, so we're working in radians. So for the principal value of tan, we know that from our table of exact values, tan of pi on 3 equals root 3. Okay, now the tan value here is positive, so we're looking at quadrants 1 and 3. So that'll be pi on 3. And that will be pi on 3. So the actual values of the solution, x will equal pi on 3, and x will equal pi plus pi on 3. Sorry, 4 pi on 3. So pi on 3 and 4 pi on 3. A little bit untidy there. Final example, we've got tan again. We've got domain there between negative pi and pi. We have to express our answer in, and we have to solve for theta. So first thing we need to do is subtract 7 off both sides. So 2 tan theta equals negative 7. Tan theta equals negative 7 on 2. Sorry, I didn't mean to put two negatives there. Okay, so this is going to be a case where it doesn't align for our exact values, so we need to, for our principal domain, we need to get the magnitude of the angle for that. So we get our calculator and go inverse tan of negative 3.5 or negative 7 on 2. So once doing that, we get negative 1.292. So negative 1.292, we've got okay, so we're looking at the magnitude of that, and remember that our tan value is negative here. So we're looking at quadrant 4 and quadrant 2, and the angles are here and here. So we've got 1.292 in there, and we have 1.292 radians in there. So you've got to find the actual values now for theta. So don't get your answer for the principal domain mixed up with the actual solution. Okay, this is the solution to this equation. Let's be clear on that. So theta. Okay, so to get the two values, now we're going to look ahead at the restriction here. We need between negative pi and pi, so negative 3.14 prox and positive 3.14. We will get that by going firstly pi minus 1.292, and we'll also get it by going no, we won't, whoops, it will be, we'll be using coterminal 0, not 2 pi. So 0 minus 1.292 to get those angles. So put those into our calculator. Let's see what we get. Approximately equal to 1.8491 radians. Just like to highlight the fact that these are radians. They do have a unit, even though we don't always write it on with our conventions, but they are radians, both of them. And negative 1.292 radians in there within the restriction on the domain. So there's our solutions.